Welcome to another edition of the Subseasonal Forecast Contest. Today is, let me check my calendar, May 6th. Today's a special edition. We normally do our discussions on Tuesday, but it's Wednesday today. And we have special guest, Jason Lynn. And actually, we're actually going to try something a little bit different here in just a few minutes. Jason's going to kind of walk us through his morning process and some of the reports and different things, technical information that he puts together for his group. So I think that's going to be really informative, getting a little bit more into the nuts and bolts than we normally do. But before we do that, we'll start with our typical attribution. Look back at the past, the most recent verification week, and maybe the past month in general, because it's certainly been an interesting month or so. And then we'll get into the forecast process. All right, so the most recent forecast verification is the April 9th to May 3rd period. I think I'm saying that right. Yep. And you can see here, this was sort of a, what's the saying? An isle of warmth and a sea of cool. So when we look at the verification, sorry, let me sort this by, I'll sort this by CRPS, our performance metric. You can see the verifications at the bottom, it was 26.5. This is still in HDDs. This is HDDs. The 30-year normal as a benchmark is about 40, and the 10-year normal is about 36. I had to double check this, but we did have that little bit of warmth here, this warm bubble, in what otherwise has been kind of a cool pattern here of recent. So Paul Roundy did an excellent job in sort of resolving the forecast there. He had the highest CRPS. He had the lowest mean, and it was closest to the verification at 30 HDDs. On the other side of things, the model guidance, the classic model guidance that we rely on, ECMWF and the CFS did not capture this synoptic period of warmer weather. Both were up around 42 HDDs, and both performed at the lowest levels, at least as compared to any of the forecast inputs in the contest. In general, it looks like most folks were on the right side of normal. Remember, in our CRPS skill metric is benchmarked to normal, 30-year normal. So 30-year normal did not do too well. It was pretty, I guess, chilly. Most forecasts you can see were kind of, to some degree, warmer than the 30-year normal. And just to, let's take a picture or see a picture of kind of what happened here. Let me start with the temperatures. I was looking at the 500. We'll come back to that in a second, but let me switch over. So let me go to the period. One more, I think, right? We're using our Dynacast tool from our friends at Maxar. Looks like I went to the wrong thing. Let me go to anomaly. Should be at anomaly here. There we go. All right, there we go. So you could see kind of a warmish pattern, in particular across the west and central, much warmer than normal, but, across key areas of the Northeast, even Chicago a little bit, Detroit. The only areas that were really kind of coolish were across the Gulf Coast. So you can see why the HDDs, which rely, especially this time of year, rely on the northern tier, were, less than normal, warmer than normal. And if we switch over and look at it from a hemispheric, which is what we were just looking at for a second, see that too. Here's that's temperature. Let's switch over to 500. There's the 500 millibar pattern. So kind of a shallow trough, empty trough sometimes is what folks might call it in the East, in the sense that didn't really have a good cold air connection. It was just in whatever cold air it had. Maybe rain-induced kind of stuff was only enough to kind of produce cool across southern areas and not really across the northern areas. Again, much of the north, in particular the west, under the ridge was warmer than normal. Let's just take a quick look at what, and we're going to open this up. Of course, anyone can open up, can interject, but we'll really open it up here in a second. I did want to pull up the Dynacast, the PDF report. So again, this was produced on April 14th. So let's just cheat and go look and see what our friends at Maxar we're thinking on the 14th. Always fun to do that. Play Monday morning quarterback a little bit. All right, so here's the Maxar forecast from that period. And then here is the EC and CFS forecast from that period. The Maxar forecast, what do we say? Verified about 26 HDD. So Maxar was definitely on the right side of the 30-year normal. In fact, we can see their scores exactly. In fact, they had the second highest score. You can see it here, the 41. So they did quite well versus, well, certainly versus me and versus the consensus of forecast there. So kudos to them. But, you know, as always, channeling my Steve Bennett, if he were on the line, he'd say, well, obviously the HDDs are important. They're important to natural gas traders, et cetera. But the pattern's also very important, right? Especially to folks who are looking at things more regionally or even at station level. And so how did the models really, or, you know, how did Maxar and the models, you know, resolve the forecast spatially? Was it just dumb luck, or, you know, was it skill? Kind of is one way to look at it. That might be a harsh comment, but anyway, point is, when you look at it spatially from a pattern, not quite as good. It would be my subjective thoughts. You know, the coldest area, I think we said earlier, was the Gulf Coast, which actually shown here is the warmest area. We had a lot of warmth across the north, in particular the northern plains and Rockies, but even the Northeast. So from a pattern perspective, other than the Southwest, it was almost opposite. Maybe opposite's a strong word, but certainly different. Let's call it different. So, you know, this could be one of those cases where, you know, right for the wrong reasons, that kind of thing. And looking at the models, I mean, the CFS, that one almost, I mean, that's really bad in the West, right? Almost completely opposite. So again, I think my main point here is there's definitely, just looking at this in 30 seconds, there's definitely some question here as to whether, you know, the spatial representation is really providing much value beyond climatology or even better than climatology. So let me stop there and open it up. Other thoughts on the forecast, attribution, things like that in terms of the forecast. And then also, and Jason, if you jump in here, feel free to also jump into, I'm really fascinated by this past month or so, since mid-April, right? When the pattern turned cold, you know, basis normal, in terms of, if you have any particular thoughts as to, you know, what's different now over this past month, 3 weeks, whatever it is, than say through much of the winter, December, Feb, things like that.
Okay, yeah, I've got a few comments. So first of all, I think, you know, this period, as you mentioned at the start, is kind of the island of warmth in an overall cold regime, and you know, transitional periods to capture in a subseasonal forecast beyond day 12 or 13 are pretty damn difficult anyway. Then you do it in a late April, early May setting, and you know, it's if you got the right side of the anomaly sign, I think you did a hell of a job here. Now that said, if you look at, say, the 200 millibar velocity potential Hub molars, we've had a pretty well-behaved circumglobal navigating, eastward propagating component of convective forcing to deal with for quite some time, and that has tended to give us some predictability whenever the signal crosses the western Pacific. Through the core wintertime period, this was at least these were periods where models at least would try to occasionally change eddy tilts across the Pacific sector and threaten to send the EPO negative and or the PNA positive and give us some bouts of cold risk. But as they do that in the 11-15, you rolled forward, you'd fizzle out, or you'd basically get completely kiboshed by the wicked positive AO. And that's kind of a segue into what's different now. So if you combine the eastward propagating mode of convective forcing that's heading through, well, it was heading through the eastern Indian Ocean, Indonesia, into the Westpac areas, essentially getting through phases 4, 5, 6 through this this period ending May 3rd verification. There was a pretty strong signal to have some MJO 5-6 influence at a time when we finally have killed off the deep, strong, vertically integrated polar vortex feature that was sitting right over the pole. So essentially, you took away the background obscenely positive AO, and you added some subseasonal forcing for Western Pacific convection, and you got essentially a MJO 6 May, late April, early May response, which made some sense.
Good, thank you.
That's my 2 cents for attribution.
Yeah. Any other thoughts on attribution this forecast before we shift into the forecast mode?
The last thing I'll say, looking back at the teleconnection forecasts, the medium range models didn't really handle the EPO very well at a late 11 to 15 day kind of lead time. The forecasts from the ensemble means were all down near neutral for like May 1st, 2nd, 3rd on a day 14, day 15 kind of lead time. But I kind of think that there was some ensemble averaging going on there, weakening the signal. If you look at some of the distributions within the ensemble members themselves, there was probably a little bit more of a skew to stay on the positive side of phase space for the EPO. And I think that helped. I remember being, warm slanted for that week in a 16 to 20 to 16 to 25 kind of forecast, and the combination of losing the big positive AO, seeing a period of MJO 5-6, and not having a negative EPO and probably skewing the EPO positive, all kind of helped stay on the warm side of normal at that time.
I think it's funny that last point you brought up about losing that really big AO. I wonder. I wonder about that. Like, sometimes we're so focused on the phase, the actual phase, negative versus positive. But the fact that we went from, this mean state up here through a lot of the winter, this only goes back through early January, but, we had this back into December too, to something that was not maybe negative, but a lot less positive, was a significant shift, to Jason's point. It meant that maybe there were more, obviously less overall positive, but also maybe even small little times and instances where it was, where you actually did see ridges across portions of the polar regions, even if not the entire polar regions, and just a shakeup, which may have been really important in terms of allowing for this shift. In other words, it's not just looking at negative or positive, but it's looking at how much did it shift, less positive or more negative, and vice versa. That could be important in terms of telegraphing the pattern changes and things like that.
Yeah, I think it's probably worth saying that not only was there an EPO miss for medium range models at a day 13, 14, 15 time frame, but they were also consensus way too positive with the AO and NAO. So essentially medium range models went back to that very positive AO background state for this end of April, early May period, and did so in error.
Yeah. I playing again the Monday morning quarterback, boy, and I'm just looking at this from a, I guess, statistical perspective, but all winter long we're talking about, hey, fade the AO, fade the AO, fade the AO, and by the way, right, that probably for most of the winter. That if you did that all winter, it probably worked out well for you. But it's like still you want to you want to be perfect, right? How would you have known that? Oh, finally, over these last 2 or 3 weeks, the AO forecasts actually were about right. This blue line, it was a little bit above, a little bit below, but basically around April 1st or so, it actually verified pretty much as is, as expected. Versus through much of the winter before that, there were small periods where it verified okay, but then you had these, it missed it. It verified much more positive, much more positive, much more positive, much more positive. Boom. How would you have known that this time was going to be different? Is there any, is it related? And I guess that was partly rhetorical, but do you think that Jason is linked to some of the changes ongoing in the tropical forcing that may have helped separate the false alarms versus the real signals, or something else? I don't know.
In the data, I don't think there's a super fantastic concrete, what I would call like an actionable piece of information that says, all right, we're done with the obscenely positive AO background state. One sort of pseudo hand wavy, but still valid approach would be, for God's sakes, it's mid to late April. It's time. It's seasonally, right. You gotta freaking tear down this deep vertically integrated PV feature just through radiative properties at some point through this period. Looking at eddy heat flux up in the higher latitudes and like northern annular mode issues. I don't see. I mean, nothing jumps out at me to say, oh, there it is. That's the event or the actual piece of information that says we're done. I think and you can kind of see there, it's sort of a grinding lower of the AO from mid-late March into the end of April. So I know using the seasonal approach is not wrong, but it's probably not the step change event that would be nice to see in a subseasonal forecast.
Yeah, I think that's a good point there too. I definitely encourage folks, I think this link we have it on the website somewhere, but if you don't.
Hey, Dave.
Oh yeah, go ahead.
Hey, this is Lynn. Could you go back to that last chart we were looking at?
Yeah, which one was I looking at? This one?
No, it was the AO index.
Oh, sorry, yeah, geez. My short-term memory is great, isn't it?
No, it's okay. It's about on par with mine. Just one comment I wanted to make in terms of the shifts. I know it's quite complicated how the AO is calculated, but if you recall that it is calculated on a monthly basis, and then it's not really done on a daily basis, although daily values do come out. So you can see that these dramatic shifts happen around the 1st, and then there's kind of a base state that it stays near. So at least it's not surprising to me that on when you look at the 1,000 millibar 14-day forecast, you see these major drops or these shifts happen on the 1st, and then it kind of hovers around some base state for a month. So you can almost predict that what it does on the 1st is going to hover around there to a certain degree, at least.
Interesting.
Makes sense.
Yeah, and I was just going to throw in real quick. This kind of goes a little bit to what Jason was saying. I think that there's a seasonal piece here too, right? The meteorologists, some of them that I've worked with in the past, used to say that once you get into the spring, you just have to kind of throw everything out. That because you know, things change, wavelengths change, responses change, and I think we have a lot more scientific evidence to support some of that stuff. Like even if this is a nice tool because it shows the MJO historical MJO composites, 500 millibars OLR, as on 10-day increments, and you know you really do see some changes as you loop through, especially between winter and summer, right? Like one of the classics, I think, is like a what's it, like phase 8, when, or is it kind of like, maybe you see it more in phase 1 here, where, you know, in the summer you see more of a warm response, and then as you get toward winter you see much more of a cold response, right? And you see during these transition periods, i.e. April, May, where things become a lot perhaps messier. Maybe that's not a very scientific view, but, and my only point is to say that, you know, relationships that occurred in maybe December, January, and February, even if the forcing remains similar, the response could be different as you get into April and May, simply because the atmosphere responds differently, again, due to different changes of wavelength and other things that occur during those times of the year. Yeah, so any other?
Last,
go ahead.
Yeah, last real quick. So if I look at, again, going back to 200 millibar VP anomalies, Hub-Molar, the big eastward propagating mode that actually contributes to the target period here for 4, 5, 6 influence, that's going through in the Indian Ocean and emerging out into the Western Pacific just after about April 20th. And signals quite strong. So, you know, there, when you're finally moving a pretty solid convective mode through Indonesia into the Westpac, we know that, you know, when you have RWDs come off of big signals in the far Westpac and eastern Indonesia, that's a pretty good spot to line up and have some wave driving, try and go both vertically and towards the pole. And indeed, if you look at time height cross sections of height anomalies from the trope all the way through the troposphere above, say, 60 north, you see the super strong high altitude, you know, above 200 millibar polar vortex feature weakened dramatically after about the 17th or 18th of April, right as this big feature's coming out of Indonesia. So, you know, you combine seasonal weakening with a pretty solid event, you know, convective mode coming out of Indonesia. That's probably the combination that finally weakened the PV.
That's interesting too. Yeah, thank you. So we have some thoughts there. I think some pretty good ideas and thoughts in terms of some of the mechanisms which may have resulted in the coldest winter I ever spent in Mount Side was in April, feels like. So, but any other thoughts? We could take a quick look here. I'll just pull up a quick look at the heating season to date. If anyone wants to see the score, let's just take a quick look at directionally correct. This is since October. Dave D'Arcangelo, who's a relatively low count, but he's made the most of it. Has the highest percentage here, and then just below that, in terms of maybe the official count, is Paul Roundy at near 70%, and then folks like me and Michael are near 50%. And then the CFS is near, I think this is interesting, even though we said it before, the CFS, if you bet against the CFS, you would have had a directional correctness of about, what, 63%. So that's interesting. There it is right there. Okay, why don't we shift gears then? Because again, we have a special segment here. I'm gonna, and Jason, would you like the screen? Would it be helpful for you to take, do the screen share?
Yeah, I'll take the screen.
All right, you should be able to there should be a button there or something like that.
Yeah, you have to let it go first. Oh,
do I? Okay, let me stop.
Yeah.
It's always hard for me to let go of things, you know.
Yes, I understand.
Stop. Okay, I've stopped.
All right, let me see if I can do it here. Boom. All right, you see the screen?
Oh yeah, cool, great.
This is actually the cross-section, time height cross-section of the trope and strat integrated height anomalies. And if we look real quick at, I want to keep that. Look real quick at the Hufmöllers that I was talking about. So this big guy right here, as it comes out through Indonesia and the far west pack, just after the 18th, 19th, I kind of think this could have been a pretty decent impetus to start this breakdown. There's an abrupt breakdown right there, and you can see there's some stuff going on. You clearly fired some ridging in the trope, and I think that probably got vertically transferred and focused on the pole a little bit to attack the PV structure. Okay, so we'll shift to the forecast. So we're going to do a little bit of a different approach today. So I'm going to show the report that I send out to my futures traders. Now, the focus when you get in the trenches is not necessarily on sex appeal or or aesthetics. It's more about getting the main message to the guys fast, and then having some decent content to back it up. So this is a very low tech delivery method via an email and bullet points with supporting graphics. But over the course of the last, let's see, 18-ish years in the business, this becomes quite effective. And this is actually the preferred method from a lot of traders that make decisions on floors. So right out of the gate, they like to see some kind of overall high-level summary. So there's some kind of overall summary statement. And today, since we're in the shoulder season, we're dealing with total degree days that are important. We haven't quite handed off the baton from gas-weighted HDDs to CDDs to be able to carry the overall weather story. So you combine them typically in this multi-week period from late April into early to mid-May. So the combined effects of gas-weighted HDDs plus electric-weighted CDDs, overnight there wasn't much of a change. So that gives the guys a delta signal off of which to play quantitatively. They like to see the comments broken up in terms of the key periods that we're interested in. So 1 to 5 day, 6 to 10 day, 11 to 15 day, and 16 to 30 day high level comments with a small amount of detail color. And after the main summary statement, they also like to have what they call like a bulk weather sentiment assessment. I've been around for 18 years. I've seen how the market responds to weather information in all kinds of market situations, be it a high price, low supply environment, or a low price, high supply environment in both power and gas. And so they like to lean on that experience. So today, with not much of a change in total degree days overnight, and we're actually now getting the shift from gas-weighted HDD dominance to electric-weighted CDDs higher than HDDs. By the time you get to the late 11-15, we're in a very tough portion of the calendar to trade around weather, absent really, really strong signals. We do have a really, really strong signal in the front 8 to 9 days of the forecast, but then we don't have much of a signal after the late 6 to 10. And that combination kind of leads you to a neutral overall base sentiment using weather information alone for the natural gas market, and probably for the extended power markets as well, east of the Rockies. So the bulk sentiment is basically neutral, but I think there's a small bullish slant to the sentiment, because in the 11 to 15 and potentially leading into the 16 to 20, there's some signs of at least seasonal warmth in the south. And that would be important because any amount of additional demand we can bring on right now is really, really important to the market to start this recovery out of the COVID-19 effects. After the bulk weather assessments, I moved through each of the main forecast lead time periods, and first talk about any substantial changes overnight, because that automatically gives you a free trade. If there's been a substantial change overnight, that will affect sentiment in that associated direction, and there will be some kind of morning market response. So a comment about the changes during that period, and then an overall comment about what is either driving the changes and or what is driving the main anomalous weather background state for that period. So in the 1 to 5 through the mid 6 to 10, here in the forecast total degree day time series, you can see rather impressive levels of total degree days, and that's obviously carried by gas-weighted HDDs because of the big cold pattern. So it's a pretty background bullish demand setup between essentially now and late this week through about the middle part of next week. And then there's a potential abrupt shift. You can see total degree days crash to near normal or even below normal levels as the pattern goes warmer. It tells you that we're not yet to the point where electric weighted CDDs or pop weighted CDDs could be strong enough to carry a bullish story by itself. So that's why that's why we're neutral. And you can see the color coded commentary here from the 1 to 5 to the 6 to 10. It shifts from purple, and blues, colder, to more oranges as the commentary shows the transition from a cold regime to less of a cold regime or an outright warmer regime. For our focus here on the back part of the 2-week forecast and into the 16 to 20, I think it's important to note on some of these comments that the jackpot multi-index teleconnection situation for cold, in the positive PNA, negative EPO, negative ABNA, negative AO, negative NAO, that full, beautiful cold supporting combination essentially falls apart after the early to mid 6 to 10. And what we're left with is not much of a signal set to grab onto from a teleconnective perspective. But that doesn't mean we don't have anything good to use for a forecast. The 16 to 30 approach right now, I think the confidence still has to be low. And for the 16 to 20 in particular, for the purposes of this discussion, my forecast, I believe, was 24 pop-weighted CDDs. I'm going with a range of 18 on the low end and 28 on the high end. So the lower, cooler range on the bottom end versus the top side risk. I'm using a blend of dynamical and pattern roll forward analogs. And I'll get to that here a little later in the message. But that's kind of the summary statement for the forecast period beyond day 15. After all of the commentary for each of the main periods, the traders like to see a summary of where the various weighted degree days are in the internal view, and they like to see a range. And so currently, we're in May, so showing the May weighted degree days, and May has both important gas-weighted HCDs and electric-weighted CDDs that come to the forefront in the latter third of the month. All right, so then we go into some of the meteorological support. I like showing ensemble means plus ensemble member distributions to show spread and some of the skewness in the distribution. It helps highlight periods where the distribution is very wide and predictability is probably pretty low. Naturally the distribution fans out and increases as you go forward in time, but you learn to calibrate your interpretation of the distribution width. So this is actually not that terrible of a distribution by the time you get to a day 13 plus lead time. And the ensemble mean agreement is fairly decent, for a near normal to below normal total degree day view. Statistically, you can break that down in multiple ways as well. So we like using the Euro ensemble, which is usually the best performing model platform. And we like to show plus and minus 1 and 2 standard deviations from the distribution around the ensemble mean for the 15-day forecast. So just 2 ways to try to look at how the forecast evolves and to get a sense of predictability along the way from a quantitative model sense. So then, being a GSDM disciple, I always go right into tropical convective forcing and try and assess what's the dominant influence from the tropics into the mid latitudes and sometimes into the high latitudes. I always like showing a 200 millibar velocity potential Hub molar here. And I really like using the wide view. I like using the 15 south to 15 north. I don't like zooming in 5 south to 5 north. I think that's too narrow to really get an idea of how the tropics can be affecting the mid-latitudes. Occasionally, I'll skew it off the equator and go 0 to 15 north if there's a substantial latitudinal dislocation of the convective clusters, but I try not to do that. I try to stay centered on the equator in a wide view. And here we see evidence of the quite well-behaved, fairly regular repeating eastward propagating mode that has been circumnavigating the globe for quite a while. And I think we're going to have another instance of this as you go through late May into early June. And this is a key component of my 16 to 20 day forecast. The interesting aspect of this eastern propagating mode behavior, though, is the widespread, very warm sea surface temperature anomalies in the Indian Ocean and even the West Pacific basically leave us more of a snail trail than we see in a lot of the historical data. The VP couplets are not as sharp. So you tend to string out negative VP through more active convection that is zonally elongated in this 15 north, 15 south band. And it's happening more frequently over the Indian Ocean, Indonesia, and the Western Pacific than it is the eastern part of the Pacific or the Atlantic at the time. So when I build a dynamically based analog using the VP signals, I'm going to perhaps use multiple regions of forcing. I'm going to take into account this quasi-stationary signal here in the far western Indian Ocean. So like a 1-2, MJO phase 1-2. And then when we get to the 16 to 20, I think this eastward propagating mode will continue chugging along. And so I'm going to use an MJO 5 to go along with it. And so I'm extracting out essentially an MJO 1 and MJO 5 mix for the 16 to 20. When we look at the RMM space, I like to show that with also the ensemble member distributions to give an idea of how focused the convective mode and the convective forcing could be using the RMM methodology. Here you can see that when you string out the negative VP signals, you tend to weaken the overall RMM projection, but there is a tilt here towards phases 1 and 2 as you get towards the back end of the 11 to 15 day forecast. And I think that makes some sense. I think it's feeling some of this quasi-stationary mode back there in the Western Indian Ocean. And then these are traders, right? They're not meteorologists, so they like to see pretty pictures. When you talk about MJO this or alphabet soup that and phase 1 through phase 8, they kind of like to see what that means in blue or red on a map where they care about. So I give them an idea of an evolution, and then I'll typically show them the evolution in historical composites that are generated from using those phases. You know, I think where there's some influence right now from Central Pacific forcing, and so you know this phase 7 with a high AAM, high global AAM background state is I think a pretty decent influencer on the current and upcoming cold pattern. And as the eastern propagating mode continues on through 7-8-1 and gets back into 1-2, you can see the cold fades. And medium range models have picked up on this, right? This is likely a portion of the mid 6 to 10 loss of the big cold pattern. Then I also show the NGO5 phase 5 composite, because I think that's where we're headed into the 16 to 20, or at least the first half of the 16 to 30, smoothing out that timing some. I also like to show various teleconnection time series plots. We had Storm Vista, the guys at Commodity Weather Group and Storm Vista, make a teleconnection index plot that shows all of the main teleconnections on one time series to make interpretation of the teleconnection big picture message easier to view in a rapid pace. And here you can get a sense. It looks like a lot of squiggly lines, but once you again become calibrated to what color is associated with what main teleconnection, this is a really efficient way to get a collective teleconnective view what's going on. Basically what you see here is through the early 6 to 10, the yellow line here is the PNA, so you got a positive PNA and negative projections of all the other important teleconnections, EPO, WPO, AO, NAO, and AB and A. So this is what I've been calling the teleconnective cold jackpot. They're all basically in phases that support cold, and indeed we're getting a very impressive May cold outbreak here through the early 6 to 10. But then you see a general weakening towards neutral. And you hate seeing this as a forecaster because it really doesn't give you anything to grab onto. And it makes you wonder, are these teleconnection index values really going to neutral? Or are you just seeing wider distributions in the ensemble averaging weaken everything and give you essentially no actionable information? Every now and then I'll break out one of the individual key teleconnections. So in this case, I broke out the EPO. It's staying a little more negative in the last few Euro ensemble mean forecasts. And you can see that here, the thick line is the most recent relative to several recent forecasts. So keeping the EPO a little more negative for a little longer, kind of interesting to maintain some kind of connection to decent quality cold air, at least into Canada. But not so sure we can get further transport of high quality cold air south of the border thereafter, when the EPO gets really, really weak towards neutral. Again, being a staunch GSCM disciple, I like showing the global atmospheric angular momentum plots, both historical values and forecasts from ensemble means, and the Euro ensemble member distribution. So interesting thing to point out here, the global integrated AM is heading positive now and is forecast to stay quite positive from the majority of the ensemble means and pretty much all of the ensemble members. And typically in May, positive AM is correlated with Western North American ridging and central, southern to eastern North American troughing. And we're seeing that play out very, very nicely here through to the early part of May. But some of us on the cutting edge, I would even call it the bleeding edge of taking some of these concepts and trying to operationalize them and get predictive value out of them. We found some occasional success with breaking the AAM into North Hemisphere and Southern Hemisphere components, especially when there's a substantial difference between the Northern Hemisphere values and the global integrated values. And we see that in this case. This dashed red line and the dashed orange lines here are the broken out Northern Hemispheric component of AAM. And it's shown to be much lower than the global integrated value, which means the majority of the AAM signals in the Southern Hemisphere. And indeed, the Northern Hemispheric AAM is most positive here at the end of April to the very start of May. And that's going to correlate with some of the coldest conditions we're going to see. It was negative back here coming out of mid-April into the period we just talked about, the end of April into the May 3rd period, which probably had some connection to the loss of cold. The island, this looks like the island of warmth in the regime of cold that we've seen this spring. So heading back here negative with Northern Hemispheric AAM is an interesting potential canary in the coal mine of sorts if you're looking for cold. This is shown to be a bit of a warmer risk signal for the Northern Hemisphere, even though the global AAM is high. And so when you can see when AAM goes lower, you tend to put more cooling in the southwest and more warmth in the mid-continent to east. This is a direction that global models have moved in the 11-15 over the last few days. And roll forward pattern analogs since late last week have actually been suggesting this, which got ahead of models, I believe. I'm going to skip forward to the European section details. I'll only say that natural gas is becoming much more of a global commodity, and it's important for North American traders to have an idea, at least a bulk idea, of where European and sometimes where East Asian overall weather-driven demand is going. And so my guys have asked for a European section. So I have to cover the European 1 to 5, 6 to 10, and 11 to 15 day general weather moves in each morning report as well. After those bulk comments, almost every trader gets through all those. And now this is the section where things can get more specific, where if they have interest in some of the nuts and bolts of what was driving the main comments in the summary section, they can come down here and start to look at more details. I rarely include stuff for the 1 to 5 because I handle that in a completely separate set of products and discussions with my short-term power and physical gas traders. So this mostly deals with the 6 to 10, 11 to 15, and the period beyond the 11 to 15. So for the 6 to 10 day period, this is where I like to start showing some of the more advanced products. When there's been a substantial change, I like showing either 12-hour or 24-hour 500 millibar height changes from each primary ensemble mean. So the GFS ensemble mean 500 millibar height change here on the left, Euro ensemble change in the middle, Canadian ensemble change on the right. And one of the key things here, you can see over North America, basically in the height change field, there's lower heights in the western part of the US. Basically, the mean trough in the far eastern Pacific is shedding shortwave troughs farther east. These shortwave troughs are crashing into the western US and breaking up the full latitude ridge, undercutting the negative EPO ridge, which is still up here over northwest Canada, Alaska, north of Alaska, and becoming more of a negative AO ridge as well up towards the pole. So that's interesting from a warmer pattern potential transition late 6 to 10 and beyond. And then I also really like showing ensemble clusters. We like using more of the full distribution of the ensemble sets. And we've had some of the vendors create these cluster analyses. I like showing a northern hemispheric view of 500 millibar height clusters for the 6 to 10, and then a 2 meter temperature anomaly cluster analysis zoomed in more over North America. And for the 6 to 10 day total, being dominated by the very cold front few days of the period, you can see highly amplified pattern lots of cold over the central and eastern U.S. But now look at the day 10 2-meter temp clusters. You can already see very good agreement across all three main clusters that you're going to reduce cold in the Midwest East and increase warm anomalies as subtropical ridging is allowed to flex northward across the southeastern third of the U.S. And then finally, I like to use pattern matched composites in an analog fashion. And I prefer using the Euro Ensemble 500 millibar height from the mean and use that pattern over the Pacific North American sector to try and capture some upstream influence and some in situ North American response. There are several regions over which you can pull these pattern matching analogs, but I find essentially the Eastern and Northeastern Pacific and across North America to perform the best. And so these are the top 10 analogs for the best Northeast Pacific to North American patterns matched to the Euro 6 to 10 day 500 millibar height anomaly. And you can see for the period as a whole, it supports the large Central North American cold event. This gets more interesting as you roll them forward into the longer lead times. Like we'll jump forward to the 11 to 15 now. So here into the 11 to 15 section, electric weighted CDDs start to become more interesting once you get beyond about May 14th. I show a Euro Ensemble mean and member distribution forecast for electric weighted CDDs, essentially showing that they go from very low levels to more interesting levels near and above normal by the time you get to the 11 to 15. And there's some dynamical analog support to that as well. So earlier I mentioned in my summary statement for the 16 to 20 day forecast, I like applying an analog mix of negative AO, positive global AAM, and a mix of MJO1 and MJO5 influence. And when I do that for a window over the second half of May, this is the analog composite that comes out. And it actually has quite a bit of similarities to some of the primary patterns shown here by not only ensemble means, but the ensemble clusters to the 11 to 15. So same 500 millibar height clustering and 2-meter temp anomaly clustering that I showed for the 6 to 10, I show for the 11 to 15, and out to day 15 as well, which drives home the point that even though you're maintaining some positive high anomalies at high latitudes that you would normally associate with colder risk, in this mix of other characteristics, you're actually shortening wavelengths and going more positively tilted with long wave features and getting cooler in the west and warmer over the southeastern third of the nation. And finally, I like taking the pattern analogs from a current period, and then the 11 to 15, for instance, we'll roll them forward into the 16 to 20. And so here's the set of 11 to 15 Euro Ensemble 500 millibar height anomalies over the Northeast Pacific and North America during the 11-15 rolled forward to the 16 to 20, assuming that there's going to be a similar evolution that drove those analogs. And it maintains this view of long wave trough positively tilted, more warmth over more of the Midwest and East. My correction to this would probably be to scale back the warmth in the Great Lakes and Northeast. But you know, a warm Texas to Midwest and Mid-Atlantic and Southeast starts to carry more of a cooling demand enhancement potential, which is pretty interesting. I think that's enough now, Dave, because I think I've only got 1 minute left, right?
Yeah, no, this is really, really good. And maybe we can stay on for a couple extra minutes. Do you have a couple extra minutes, Jason, or how are you done?
I do have a couple extra minutes. Okay. And so kind of the last thing I wanted to show, because I like this approach quite a bit. I've had pretty substantial success with this at various times in both the core cold season and core warm season. It tends to have bigger problems in the shoulder seasons, but the analog approach is used because the forecast models, the numerical weather prediction models that we rely on so heavily are flawed, right? So in the face of extreme complexity, we like to try to simplify and use these historical approaches. Analog approaches can be very useful, but they're only typically as good as the relevant analog parameters on which you use to find the patterns that you're interested in. So using just snapshots of height anomalies isn't the most dynamical way to go, and leaves you open to spurious connections. Well, you're just catching snapshots of dynamically unrelated evolutions. So I've worked with Storm Vista on establishing a set of more dynamical analogs where we use the tropical convective forcing parameters themselves in terms of spatial pattern matching, but also spatial evolution pattern matching. So I found the velocity potential and the OLR at times, the outgoing long-wave radiation, combined with VP to be the most effective. And so here, basically, we take the evolution, the spatial evolution of velocity potential and OLR during the 11 to 15 off of the Euro ensemble, which has some skill for these parameters at that time scale. And it's that spatial evolution that is then rolled forward and matched. That spatial evolution is matched during the 11-15, and then those evolutionary matches during the 11-15 are rolled forward to the 16 to 20 and the 16 to 30. And in this case, I'm showing the 16 to 30. So the evolution of VP and OLR suggests that this shift in the pattern away from strong cold in the Midwest and East to more cool in the Southwest and a warm skew for the southeastern third to half of the nation is suggested to have some durability and some legs as you go through the 16 to 30 with this approach. And that wraps up this particular report. And I think that's probably enough for today.
This is, I mean, I'm blown away. This is really super awesome. Thank you. I know we don't have a lot of time, and I'm guessing folks may have questions. Jason, is it okay if I do get some questions offline or something? Is it okay if we send them over to you? If I, via email?
Sure, I'll tackle some of them. Sure.
Okay. And I guess I'm thinking folks may have some questions on the GSDM and clustering, but let me put that, Michael or Lynn or Sean, any particular questions come to mind for Jason in the next couple minutes?
This is Lynn, and well, I just wanted to say thank you. I thought that was really great as well. There's a lot in there. I probably have a billion questions, but could you just repeat again what you said about using analogs and not use, the 500 millibar height obviously not being as useful? And what do you find to be the most useful analog to use or quantities to put in for the to base your analogs on?
Sure.
Sorry.
Yes. I find that when we deal with NWP, numerical weather prediction, beyond about day 8, all of these upgrades at the various modeling centers, and I use upgrades in quotes, have pushed to us, the operational users, have essentially broken a lot of how the models handle the boundary layer, and in particularly surface heat fluxes.
Yep.
So 2-meter temperatures have been, an easy way to get you into trouble in a longer lead forecast, even though the model may have more of a clue what the hell's going on at 500 millibars or at jet stream level 200 to 250 millibars. So one way to tackle that doesn't put you behind the 8 ball in a regime change that, say, a bias correction scheme would. Bias correction schemes are nice over the long term, but in a regime change situation, they're going to have you late to the party. If you're in a very, very cold regime and the models aren't cold enough, they're going to be, you're going to be correcting colder by the time you go into a warmer regime. And if that flip is fast, your bias correction scheme is actually working against you.
Yeah.
And these major regime changes are actually super freaking important to what we do in energy trading.
Yeah.
They're inflection points in sentiment and oftentimes very strong responsive inflection points in price. So one way to address this is to set the model up for success. Is to use the parameters for which it has better dynamical quote unquote understanding and handling performance, and then work your way back into the boundary layer. And one really good solid way to do that is to analog off of the 500 millibar jet stream patterns for a 6 to 10 with a lag 0. We found that you can improve upon even the Euro ensemble mean, especially when there's a lot of snow cover, by using 500 millibar height anomalies for the 6 to 10 composite, and then use those to analog down to the 2 meter temp anomalies. That also works quite well for the 11 to 15 and the lag 0. Moving past the 11 to 15, you start to get into this subseasonal haze of the mix between weather and climate. Dynamics are still very important, and as a GSDM disciple, I believe tropical convective forcing, the interaction between the tropics and the mid latitudes, the further interaction between the mid latitudes and the high latitudes comes into play, and so we might as well take advantage of that. And I think taking advantage of the GSDM paradigm and framework says not only can you use the spatial pattern of the flow, but you can use the spatial pattern of the forcing parameters as analog factors to potentially improve predictability over and above what climate models can do and screw you in errant 2 meter temperature anomaly forecasts. So a combination of 500 millibar height anomalies during the 11 to 15 rolled forward into the 16 to 20 and forward into the 16 to 30, combined with analogs of spatial evolution of velocity potential and outgoing long wave radiation from the 11 to 15 rolled forward into the 16 to 20 and 16 to 30. That combination has proven to be pretty valuable in usually in first sort of handicapping climate models and sort of sanity checking what a climate model forecast is coming up with. But this approach has outright beaten climate models many times.
Well, that makes, thank you for that. That makes perfect sense to me, especially because, or one of the major deficiencies I know of in climate models is that they're running, to save time on the computation time, they're running some of the very important parameterizations not at every time step, and that can be disastrous on longer timescales in terms of their forecasts. So,
indeed,
it seems to is a good way around that, or at least to compensate for that problem.
Yeah, I think it does a pretty interesting job of cutting a lot of corners without throwing a lot of information out. Yeah. The GSDM framework is built on interaction across scales, both spatial scales and time scales. And so by leveraging analogs that use those parameters, I think you're staying much more dynamically true and dynamically relevant to the analog process. So you're not just pulling things out of thin air that happen to match what a snapshot in time of what could be incredibly diverse and different evolutionary processes from historical cases, right? You're at least on a similar dynamical path then, which should theoretically increase your predictability. Now, bear in mind the GSDM also is true enough to the science to say that there are times where we don't know what the hell's going to happen. There are times when the nonlinear system is so noisy that predictability is low. It's not that the answer's out there and we dumb meteorologists are fumbling around trying to find it. it may not be there. It may not be decided yet at that lead time. Then there are times where there are either big signals or a multiplicative combination of multiple modest or weak signals that together dramatically increase predictability. And I think these kind of frameworks help us sniff those out better than just going with the Euroclimate model or the CFS.
Thank you.
Anything else, Dave?
Oh, sorry about that. I was on mute. No, I was just saying that I think, yeah, I think this is great. I want to be respectful for other folks' time. I feel like we can probably be on here for another hour. But if you do have questions, just, you don't have Jason's email, just please send them to me. I'll make sure to get them over to Jason. I love this format, Jason. I really do. I definitely think we should do something like this again. I think it's so informative to see you actually walk through your process with that kind of detail. So thank you so much for doing that and taking the time to do that and sharing, all that knowledge and information with us. This is really wonderful. So, yeah. So unless there's anything else, why don't we leave it there? Again, send me questions if you have them for Jason. We'll definitely try to have Jason back to maybe go through some of these topics in more detail. GSDM, clustering. There's some great things there. But otherwise, thank you so much. And I hope we see you guys again next week.
Yeah, thanks.
All right. Bye, guys.
Bye.